In this video, we're going to be looking at why we want to restrict the domain of a quadratic to make it invertible. So the first thing we need to see on our screen is that I actually have three different functions graphed, but it is one quadratic. And if I were to invert this entire quadratic, I would get this sideways parabola. And this sideways parabola are my square roots. So we know that the opposite of squaring is taking the square root. Also, we should know that in order to fully get rid of a square, we would take a positive square root and a negative square root. And so we have the entire shape here. If I were to also put in the line y equals x, we can see that our red function, our red quadratic, is reflected across y equals x to get us this entire shape over here. The problem, and we can actually see that over here with the fact that I had to use two different equations, is that when I take my entire quadratic and I invert it, I get this sideways parabola shape. The unfortunate bit here is that this sideways parabola shape is not a function. We know that in order to be a function, you can only have one y value per x value. But say that I put in the line x equals 5. There's a vertical line here. We can see that it crosses the function here at 1.23, but it also crosses the function here at -3. So it's not a function, even though I just used that word. These two together fail the vertical line test, and therefore it's not a function. And when we're taking an inverse, we don't want that to happen. We want to be able to take the inverse of a function and for its inverse to also be a function. If we look at our equation, we actually see that mathematically, this happens naturally. Mathematically, these are actually split already so that each individual one is a function. The normal one, the positive function, is this blue one. So I'm going to turn the green one off now. If I turn the green one off, I can now come back over here and, hey, I actually just have a function. If I even went back to x equals 5, we can see now that I'm only intersecting my graph at this one point. I no longer have the bottom part, so I no longer have to worry about it not being a function. But this half, this blue part, isn't the entire picture of my red part. But they came from each other. It is still the inverse, but it's only half of the inverse. And so the question is, well, what half is it? So one of the first things I can do is I can look at the table of values of these. So I can look at this table of values and I can look at this table of values. We know that in a table of values, our x and our y should be switched. So I have the point 0, 1 on my quadratic, which means I should have the point 1, 0 on my square root. And I do. It's right there. Sorry, right there. So I have that 1, 0 point. But I can also see that I have 1, 4 on this one. So if I plug in 4 here, I should get, I got 1. It shows up right there. But what I'm noticing is that the points that I'm seeing show up on my blue one. See how these ones that say undefined? Those are not the ones that are showing up. The ones that are showing up are when I was on the positive side of my graph. So -1, 0, that should be 0, -1, and it was. 0, 1, that should be 1, 0. 1, 4, that should be 4, 1. So these ones, the ones to the right of the vertex of my quadratic, are the points that are giving me this inverse that is a function. So I can show this in one more way altogether. What we're going to do is we're going to do what is known as restricting the domain of my quadratic. So we're not going to take the entire quadratic. We're only going to take half of it. And we're going to restrict the domain to where x is greater than or equal to, well, my vertex was at -1. So greater than or equal to -1. And now, once again, we should see this relationship. I only have half my quadratic, but I still see that point -1, 0, 0, -1. The point 0, 1, the point 1, 0. If I could still click on the 4, 1 relationship, we would see that one as well. So quick recap here. When I did not restrict the entire domain, so if I were to get rid of my restriction again here, when I tried to invert this entire quadratic, I ended up with something that was no longer a function, which is something we don't want to happen. But If I restrict this domain to where x is greater than where the vertex was, greater than or equal to where the vertex is, then I get rid of this problem. Since I no longer have the left-hand side of my quadratic, when I invert it, I no longer have the bottom side. Now, both the function I am inverting and the inverse are functions. Both of them would also now pass the horizontal line test and the vertical line test, making both of them 1 to 1.